Hi, myself Dr. Jeglori, Associate Professor of Physics, Institute of Aeronautical Engineering. Today, I'm going to tell about the fabrication of nanomaterials. In that, one of the fabrication method is vapor deposition technique. So, in that, we are going to see about the physical vapor deposition technique. So, in the vapor deposition technique, vapor deposition refers to any process in which materials in a vapor state are condensed through condensation, chemical reaction or conversion to form a solid material. So here vapor deposition means that a process, it is a process. So what type of process? Material in a vapor state. Material in a vapor state condensed through the condensation or chemical reaction and converted into form, converted to form a solid material. So this is the vapor deposition. So vapor deposition is a process. In this process, material in a vapor state are condensed through condensation or chemical reaction and converted into form a solid material. So these processes are used to form coatings to alter the mechanical, electrical, thermal, optical, corrosion resistance and wear properties of the substrates. That is, these processes are used to form coatings to alter the mechanical, electrical, thermal, optical, corrosion resistance and wear properties of the substrates. So what is the wear properties? So what is the wear properties? Wear properties are temperature, sliding speed, hardness, modulus of elasticity, load and composition of material. So the wear resistance is influenced by the contact temperature. The wear resistance is influenced by the contact temperature. So since the hardness and yield strength diminish as the temperature rises, abrasive wear would increase. So here the hardness and yield strength diminish as temperature rises. As temperature rises, abrasive wear would increase. What is abrasive wear? So the displacement or loss of material formed from a surface due to hard particles forced along and moving against a solid surface. That is abrasive wear. So the displacement or loss of material from a surface due to hard particles forced along and moving against a solid surface. So this is abrasive wear. So the hardness and yielding strength diminish as the temperature rises, abrasive wear would increases. It would increase. So here in vapor deposition technique, it can be classified into two types. One is physical vapor deposition technique, another one is physical vapor deposition technique and chemical vapor deposition technique. So first we shall see about the physical vapor deposition technique. So in this physical vapor deposition technique, so this type of deposition is one of the simplest and most popular synthesis method to produce nanoparticles. And it has been very successful. It has been very successful and versatile in fabricating nano belts. So in fabricating nano belts and nano wires with various characteristics, we can get it nano belts and nano wires with various characteristics. So physical vapor deposition is one of the simplest, most popular synthesis method which we are using, and it has been very successful and versatile in fabricating nano belts and nano wires with different characteristics. The basic process of this method is sublimating source materials. Sublimating source materials in powder form at high temperature. Keeping at a high temperature, we are making this as a fine powder. So, This process includes it supplementing source materials in powder form at high temperature. So, say source material is converted into powder form when keeping at high temperature, and subsequent deposition of the vapor in a certain temperature region to form desired nanostructures. So, subsequently, that vapor will be deposited on a substrate at certain temperature region. We can get nanostructures, desired nanostructures. So, the primary PVD methods are iron plating, ion implantation, sputtering, and laser surface alloying. So, physical vapor deposition is a vacuum deposition technique in which solid materials are converted from a condensed to a vapor state and back again on a substrate, which results from a thin film. So, vapor state will be condensed, and then that condensed state of particles will be coated on the, or back again we are making formation on the substrate. So, here in this technique, solid materials are converted to form a vapor state and then condensed and placed on the substrate back again. So, which results it forms a thin film. PVD involves a conversion of solid material into gaseous phase by physical process, which is then cooled and redeposited on a substrate as per requirement. That is, we have a solid material. So, this solid material, when we are heating, that is, it may be metal. So, when we are heating, so as keeping on temperature, so that this solid material converted into gaseous phase. So, it converted into gaseous phase. Gaseous phase, and then it is cooled and redeposited on the substrate. So, taking solid material and convert into gaseous phase, then let it be cool this one, so that what happens, it can be changed or converted in condensed. So, this will be redeposited on the substrate. So, we are allowing gas in the vapor state. So, that is solid material. When heating this solid material, it converting to gaseous phase. So, now at this gaseous phase, let it be cool, so that it will be condensed. So, then after condensation, that will be redeposited on the substrate. So, suppose this is the substrate, it will be redeposited on the substrate. That is, through the condensation, the condensed particles will be redeposited on the substrate, like this. So all the reactive PVD hard processes combined the following steps, a method for depositing the metal. So combination with an active gas such as nitrogen, oxygen or methane. Plasma bombardment of substrate to ensure a dense hard coating. So here we are giving some power supply, so that here what happens, the metal when is heated, the metal when it is heated, so it will be comes into gaseous phase. So after that it will be cooled, so that will be placed on this substrate, that will be placed on the substrate. So this is the target material. So when heating this material, solid material, so it converted into gaseous phase, so that the through the vapor, through the condensation, the condensed particles are coming and redepositing on the substrate here. So likewise, we can form a thin film on the substrate. So this would be happens in the vacuum chamber. That is, we are connecting some vacuum pumps to this apparatus. So the first nanopowder manufacturing process developed and scaled up at Nanophase Technologies Corporation. So it was patented as a physical vapor synthesis process. So PVS process, physical vapor synthesis process. So in this process, first there is application of energy to the precursors, so that when energy is applied to the solid precursors like a metal precursor, so when energy is applied to the metal precursor, so it will generate a vapor state. It will generate vapor. So to generate vapor state, it will be heated at high temperature. So first energy is applied to solid precursor in order to generate a vapor at high temperature. So a reactant gas is then added to the vapor, and then it is cooled at a controlled rate and condensed to form nanoparticles. So the nanomaterials produced by this process consist of discrete, fully dense particles of defined crystallinity. So this method typically produces particles with average sizes ranging from 8 to 75 nanometers. So here Nanophase Technologies uses this type of process in the commercial scale to produce nano zinc oxide and aluminum oxide nanoparticles. So let's see their setup of physical vapor deposition technique. Physical vapor deposition technique. So I'm drawing the figure which is related to so in this technique there is a solid metal precursor a solid metal precursor So when heat this solid metal precursor, that is, it comes into vapor state. That is, we are applying some jets of thermal energy is applied. When the jets of thermal energy is applied to the solid metal precursor, it converted into vapor state. So vapor phase is formed. And then a reactant gas is added to this. A reactant gas is added to this vapor. Then it gives clusters. It forms molecular clusters are formed. And then we allow it to cool at controlled rate. So we'll get condensed particles, that is nanoparticles are formed. So condensed nanoparticles are formed. So these would be condensed nanoparticles are redeposited on the substrate. So these condensed nanoparticles are redeposited on the substrate. So condensed nanoparticles are deposited on the substrate. So this is the substrate. So this is the condensed nanoparticles which are deposited on the substrate, so that we can make a dense thin film by using this physical vapor deposition technique. So that technique which is used in the by the that is Nanophase Technologies Corporation. So development of golden colors using physical vapor deposition technology. So development of golden colors using physical vapor deposition technologies. So in this, the objective was to obtain different shades of golden color on metallic substrate. So initially we have a substrate. So on that, by using a physical vapor deposition technique, we made coating. We made a coating to give different shades in colors. So that the here to obtain different shades of golden color on metallic substrates. To carry out this, the optimization of the physical vapor deposition process of different metallic targets and reactive gases was carried out. So as can be seen in this diagram, in this photo, so it was obtained from a intense gold to a lighter gold with pink tones. So from here to here, so there is a variation in the colors. So here we are getting intense gold to lighter gold with pink tones are same. So by this we can get these type of shades by the coating of nano particles. So another example, development of metallic films as barriers against corrosion. So in this, corrosion occurred on a metallic substrate coated with different metallic layers when it is exposed to certain environmental conditions. So the solution proposed was the development of an inert metallic coating under these environmental conditions and deposited by means of PVD, physical vapor deposition method. So the purpose of the coating is to provide gate resistance to wear and corrosion. So these are the best two examples for this physical vapor deposition techniques. So what are the advantages of this physical vapor deposition technique? So it does not require the use of chemical reagents or cleaning post treatments. So it has a very low environmental impact. So physical vapor deposition can be applied to any inorganic material. The coating obtained by this physical vapor deposition have a great adhesion, resistance and durability. So in this technique, it allows great control of composition and thickness of the coating. So the disadvantages of this technique. So in this process, it uses complex equipment and they are very high cost. In production, speed of PVD coating is very slow compared to the other deposition process. The PVD technique is limited in substrate with complex geometries, stopping the newly formed particles from agglomeration is also be difficult. Coming to the application of PVD technique, it can be used in the magnetic film coating for decorative purposes, widely used in the jewelry area, stopping the newly formed particles from agglomeration, and it can be used as a coating for solar glasses or mirrors, which acts as optical interference barriers and reflective barriers. Conductive layers of palladium or carbon for electron microscopy samples, and high hardness coatings of composite materials, resistance to wear and corrosion, widely used for the improvement of mechanic tools. These are the applications of the physical vapor deposition technique. So the references are Engineering Physics by K. Tyagarajan, McGraw Education Private Limited, New Delhi. A textbook of Engineering Physics by M.N. Avadhanulu, P.G. Kshisagar, S. Chand and Company, New Delhi. Engineering Physics by Dr. M. Armugam, Anuradha Publications, Chennai. Engineering Physics by P.K. Palanisamy, 4th edition, SciTech Publications, India Limited, Chennai 6,70,000. Engineering Physics by Dr. K. Vijay Kumar, S. Chand and Company, New Delhi. So these are the textbooks to refer the physical vapor deposition technique. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.